Well, to help us out, we can see that these points kind of form a line. And we can draw the line that best fits this data. Now on this line, we can see that our best guess for the price of the house is this point here over the line, which corresponds to $120,000. So if you said $120,000, that is correct. This method is known as linear regression. You can think of linear regression as a painter who will look at your data and draw the best fitting line through it. Now you may be asking, how do we find this line? So let's try a small example. Let's try to fit the best line that fits through these 3 points over here. Obviously, best line is subjective, but we'll find some line that works well. Since we're pretending to be a computer, we can't really eyeball the line. So we're going to start by drawing a random line and seeing how bad this line is. In order to see how bad this line is, we calculate the error. So we're going to look at the lengths of the distances from the line to the 3 points. And we're going to say that the error of this line is the sum of those 3 lengths. Now what we're going to do is to move this line around and see if we can reduce the error. So let's say we move it in this direction. And we calculate the error again. It's given by these yellow distances. We add them up and realize that we've just increased the error. So that's not good. Let's try moving in the other direction then. We move it and again calculate the error. It's given by the sum of the green distances. And we see that the error is smaller. So we say, let's take that step. If we continue doing this procedure several times, we'll always be decreasing the error and we'll finally arrive to a good solution in the form of this line. This general procedure to minimize the error is known as gradient descent. In real life, since we don't want to deal with negative distances, what we do is instead of adding the distances from the line to the points, we actually add their squares. This procedure is called least squares. So we're back here on the summit of Mount Everest, and we're trying to descend to the bottom. Now in this context, the higher we are, the larger our error is. So descending means reducing the error. Now what do? Well, we look at our surroundings and try to figure out which way can we descend more. That's the equivalent of jiggling the line around and looking for the movement that reduces the error the most. So for example here, this seems to be the direction that makes us descend the most. So we take a step in that direction. That is the equivalent of moving the line one step in the direction that decreases the error the most. In a way, we're moving the line closer to the 3 points. So now we've reduced our error and got closer to the bottom of the mountain. Then we can start the procedure again, looking at our surroundings and deciding in what direction we descend the most, or equivalently, in what direction we get closer to the points. Then we start the procedure again and again, looking at our surroundings and deciding in what direction we descend the most, or equivalently, in what direction we get closer to the points. What we just did was reducing the error until we find its minimum value, which gives us the best line fit.